that this is just the beginning. Every one of these flights is a step closer to a fully operational Starship that will take us beyond Earth orbit. And with our pace of rapid iteration here, the Moon and Mars are not nearly as far in the future as you may think. In fact, we're planning to send Starships to Mars as soon as 2026.
Which is when the next Mars transfer window opens, which is under 2 years from now. Now, you might be familiar with the Starlink logo, which you see there on your screen. It's an iconic representation of the Mars transfer orbit, also called the home and transfer orbit. This transfer window, or the time between the time when Earth and Mars are closest to each other, opens every 26 months and is only open for about 2 to 3 months at a time for a vehicle with Starship's power.
Lining up a launch to Mars is similar to how we launched to the International Space Station, where we timed the launches to match the station's orbit. If we didn't do this, we would need more propellant and more time to get there.
So the first opportunity we have to fly Starships to Mars, we plan to go for it. These first flight tests to Mars will be uncrewed and will test the reliability of landing in tech. If those landings go well, the first crewed flights will soon follow after that.
Right now, our flight tests are focused on proving out reusability of both Super Heavy and Starship. In 2025, we'll continue that focus while also potentially flying our first Starlink missions and demonstrate capabilities central to our role in taking astronauts to the Moon as part of NASA's Artemis program. Starship will be used to land astronauts on the lunar surface on NASA's Artemis 3 mission, which will put the first humans on the Moon since 1972.
One key capability will be the ability to refuel Starship on orbit, which you can see there on your screen, with a Starship prop tanker docked with a fuel depot. Next year, we're planning to test this capability by launching 2 Starships and having them meet up to transfer tons of cryogenic propellants. Now, when the time comes to land on the Moon, Starship will link up with NASA's Orion spacecraft in lunar orbit, where astronauts will transfer over for their descent. Now, once on the lunar surface, they'll ride the elevator down in their Axiom EMU spacesuits from Axiom Space and leave the first footprints on the Moon in more than half a century, kickstarting humanity's mission to establish a sustainable presence there. And coming soon to a moon base alpha near you, Starship Enterprise Edition.
That is so exciting, and all the advancements that are going to come in order to enable all of that. Now, our rapid iterative development approach has been the basis for all of SpaceX's major innovative advancements, including Falcon, Dragon, and Starlink. Today, we're testing hardware and systems, and we need to know how they perform under the most extreme conditions. And what's more extreme than the flight environment? We'd much rather find the bugs and limits now during testing than later on when there's more on the line.
And to reiterate, while we do determine an acceptable level of technical risk on our vehicle and pad to learn as fast as possible, we accept no compromises when it comes to the safety of the public or our team. So all of that to say, this is only the 6th of many future flight tests of Starship before it becomes fully operational.
And we tend to do our testing out in the open, just like today. And that means people sometimes see when our hardware doesn't perform as we planned during that testing. And that's okay, because this is exactly what we are testing for, to physically see if hardware performance matches what we expect it to do or not. Even more with today's test flight, where we're purposefully pushing the ship beyond its limits.
Starship development is also being aided by Starlink space-based connectivity. You might remember the Starlink panels that are incorporated into Starship, and you can see them there on your screen, those rectangular panels on Starship's nose cone. Starlink brings us the epic views in space and on re-entry, and also helps deliver us critical flight data engineers need to continue development.
Yeah, Starlink continues to help us push the limits in space in the short term by providing great views and real-time data on our next few flights, particularly through re-entry, which spaceflight veterans know that is historically a period of blackout for all communications within spaceflight.
Outside of Starship, Starlink has helped people across the globe, particularly in rural and remote areas that have been underserved by traditional broadband internet.
Yeah, and soon, Starship will deploy our next generation Starlink satellites, which will continue to increase our capability to connect even more people with high-speed internet all around the world and beyond. Now, as we continue to prepare for our next several flight tests, we recently performed a cryo-proof test of the Starship for Flight 7, our first operation with the vehicle debuting a number of major milestones. The ship has been stretched to make room for larger propellant tanks, increasing the propellant capacity from 1,200 tons to 1,500 tons. The forward flaps also got a redesign. They have shrunk in size and they also shifted in location, and both of these things will help better protect them during entry heating while still providing control. There's also a wide range of upgrades that will make the vehicle more reliable, adding redundancy to and the ability to operate for longer durations in space.
One unique aspect of a trip to Mars are the different conditions ship will see when entering the Martian atmosphere. Now, it's difficult to simulate Mars's atmosphere when re-entering on Earth, so we've been testing a variety of heat shield materials inside a specialized plasma jet chamber at the University of Illinois Urbana-Champaign, where we're able to more closely simulate Mars's 95% carbon dioxide atmosphere.
Aside from looking awesome, this is important testing. The intense heat of entry will cause the CO2 to break down into its base elements, exposing Starship to atomic oxygen, which increases surface heating and can cause materials to oxidize or start to break down. Spacecraft entering over Mars encountered more than twice the amount of atomic oxygen at their peak when compared to Earth, and that is certainly a unique challenge.
Now, you could see those two towers in the back there in the distance at Starbase. Starbase is really coming along just as rapidly as Starship itself. That second launch tower will be coming online next year, and it will allow us to increase our flight cadence and test even more frequently. And just a few kilometers away from the two towers, our cutting-edge 1 million square foot star factory is nearing completion with the goal of producing hundreds of ships a year.
Yeah, that might sound crazy, and that's because it is. If you can imagine a future where we are flying and catching a fleet of boosters, which is the lower portion of the vehicle, that fleet is actually pretty small compared to the potentially hundreds of ships, the uppermost portion of Starship, that will be flying in that future vision.
Yeah, exactly, Kate. Those ships will be staying in space for long-duration missions to go to the moon or Mars, or become tankers for refueling, or any number of other uses. But the boosters will come back and turn around to launch the next ship. So in order to hit that production cadence of hundreds per year, we're rapidly building out Star Factory, which is our Starship production facility in Texas.
And views of that Star Factory there. Now, this place allows us to move system integration work earlier in the build process, which means more efficiency, higher quality, and ultimately faster production. Starbase is an incredible place to be right now. There really is nowhere else in the world like it. You know, hint, hint, nudge, nudge.
Now, what you might be hinting at is the good news is we are hiring. If you love what you're seeing, check out our openings at Starbase. On the engineering side, we're looking for vehicle design engineers across structures, propulsion, and integration.
And if you're a hands-on tech, we're looking for integration technicians and welders that can help us hit our goal of building a Starship every 8 hours. And to do that, we need builders.
Yeah, we're definitely going to need a lot of builders to get that down to just 8 hours.
Right? Now, beyond that, in order to keep Starbase growing, we have all kinds of roles, from baristas to HVAC technicians to EMTs. So chances are, if you're looking, we have a place for you. Visit SpaceX.com/careers to see all of our openings.